Hi, good morning, everyone. Thank you for joining us today for the webinar session on embracing PCB design challenges through IPC design standards and certifications with Ms. Cheah Lan. My name is Iza and I'm with SHRDC, and together with my colleague Gilin will be your moderators for today. Before we begin, we're just going to go through some quick housekeeping rules. The participants' audio and video capabilities will be disabled during the webinar. Unfortunately, due to the restraint of time that we have, the raise hand reaction will not be attended. And if you have any general questions regarding today's session, please type them in the chat box. For optimal viewing, we recommend the speaker view that you can select on top of your screens. Also, this session will include brief polls during the presentation, so please pay attention to your screens and throughout the presentation. And if you have any questions regarding the topic of today's session, you can type your questions in the Q&A box located at the bottom of your screen, which we will address at the end of the presentation session. Right, before we begin, let me just give a brief introduction of our speaker today. Ms. Cheah Lan is currently the Master IPC Trainer for IPC Design in Asia Pacific. She was appointed in 2013 and has 14 years of IPC Certified Designer Training experience with more than 400 participants certified in IPC CID and CID+. She promotes the importance of standards, provides technical consultancy services and knowledge expertise to the regional PCB design industry through training and development courses. Prior to joining the education industry, Ms. Cheah spent 17 years working in full-time research industry for electronics and microelectronic systems in hardware and software simulation and modeling. Ms. Cheah graduated with a Bachelor of Engineering with Honours from the University of Essex in 1993 and Masters of Science in Engineering from the National University of Singapore. This session will take about 45 minutes to an hour, and without further ado, I'd like to hand over this session to Ms. Cheah.
Okay, good morning, everyone. Let me just share the screen first. Iza, could you enable the screen sharing for the participant?
It should already be.
Oh, okay. Share screen. I couldn't share the screen. Oh, okay, now I can share the screen. Okay, very good morning, everyone. So thank you very much, and thank you, Iza, for the introduction. I'll just go straight to our short 1 hour presentation today to look at the summary, what we'll be discussing or talking about. So these are the topics which we will briefly look at. First is to get to know what is IPC, and because maybe some of you are new and you would like to know a little bit detail, like where can I get the information. Next is to look at some frequently asked questions based on the IPC list. Next is to look at design standards. So what are design standards, to give you an intro, and then how to use the design standards for solving the PCB design problems. So you have the standards. So the next thing you want to do is, how do I refer them, or how can I use them? So these are the things that you might want to know. I guess the most interesting portion would be the case studies and examples. So later on, we will be showing you some real case studies that I have done with some companies. And we can show you how they can apply standards to their real life problems. And the last item is probably just to get you introduced to something called the design certification, which is where you take a course and then you take the test and you get certified, right? So these are things that we're going to discuss today. Okay, right, so quickly we look at what is IPC. So the name, actual name of IPC stands for Association Interconnecting Electronics Industries. And this is established in 1957. It has a voluntary committee to actually come up with the standards, right? Well, you see that the name IPC and the actual description isn't the same is because IPC was actually quite branded. So they kind of retain the IPC, but it's no longer representing the old name, which stands for Institute of Printed Circuits. That's the old name. But now they actually came up with a new name, which is more relevant in the modern world. What they have is an annual IPC Apex Expo in the US, normally in San Diego and I think it's San Jose. So they will hold this to have an interaction with all the vendors, suppliers, and customers and companies coming in together on the show floor to share information, latest technology. So they have international offices around the world as well. So we have one here in Southeast Asia. The main IPC in Southeast Asia is located in Bangkok, actually. Okay, so let's look at a little bit of FAQ. So we want to know more about IPC. We can log on to this website, ipc.org. And later on, I will show you where we can get design information. Okay, the next question we want to discuss is are standards mandatory? Because maybe as a newcomer, or maybe you have been working on the PCB for some time, you may be thinking, if I refer to the standards, do I have to compulsory follow strictly what the standards like parameters are or the numbers are? So, we're going to tell you that. And then we talk about where did the standards come from? Is it from a single company? Is it a single person or organization? And who can control the standards? Like, is it open? And if you have a big project and you find certain useful information, can you make that into a standard, right? So probably the answer is yes. And how can standards help us? So these are things that we will talk about. So first thing first, we look at the website. So the website we have here is IPC.org, and you will see that I've highlighted on the slide, there's this IPC Designer Certification Program. And this is the portion where you can click into the system and you can find useful description about how this program will work. So this program currently is running online for Southeast Asia. So we have a class going on in 1st to 9th of July. And we are open for registration if you're interested. Okay, so who created standards? So standards are not like individual company or organization proprietary. So what happens is that the PCB industry and their companies would form what we call a voluntary consortium for standards creation. So the process here is to apply, right, ballot and approve for publication. So they will come for meetings and collectively agree upon certain maybe numbers or technology or process, and they have to ballot and approve, right? So that's why you see standards are always evolving. They are not fixed, as in like you always use the same thing. So one of the most commonly used standard is IPC 610, and you will see that it has probably evolved like up to version H, I, J, right? So every 2 years, they may change. And for design standards, they are kind of concept-based. So maybe they are not prone to changes so quickly. Okay, so then the next question is, are standards compulsory or mandatory? So the answer is actually no. So if you are using standards, and what happens if you design or maybe your requirement doesn't fall within the standards. So what do? Like, you can't fit into this standardization. So not to worry, there is a statement in your contract that you could actually say to your vendor or your customers that as agreed between user and supplier. So it's a very useful word, acronym to use is AABUS, right? So if you have a design or something that doesn't fall within the standards, then you can specify it and put it in a contract, and this is going to be valid, and it's actually called AABUS, right? Okay, and you have to remember, standards, again, are not compulsory because they are best practices. So best practices means that if you're not sure of doing something and the other companies or consortium has already done many tests and with experience, if you follow the standards, it means that you will have less mistakes, less respin, and of course, less cost involved in producing your electronics product, right? So this is what we meant by standards. Not mandatory, but if you happen to use them, they are best practices, and saves you a lot of time and cost. Okay, the next item is how to use the standards. So we have the most basic performance specification for electronics. So it's class 1, class 2, and class 3. So maybe you have heard of it, or maybe you're not aware, but we'll do a poll and we'll check. And there's also something called manufacturability level, ABC, which we also teach during the class, which is very useful because they are actually for like DFM purposes. So if you're doing DFX, so DFX, Design for Excellence, has 3 main components. So they are DFM, DFA, and DFT. So if you're doing this, then most likely you might want to know what is the level ABC, because most of the time people will have already know class 1, 2, 3, right? And of course, it also covers design for reliability, which is part of the class 3 products. So we also talk about how to make your design a lot more robust compared to just normal requirements. And it also includes quality inspection, acceptance criteria. So anything that you need to do or create or produce an electronics product, it can be found in the IPC standards. And last but not least will be the communications with your PCB industry supplier and personnel, because you need to know the terminology that is being used specific in this industry. Because if you don't, you might have like miscommunication, and your job may get rejected, or maybe they'll come back to you and ask you to change some stuff. So the communication part is actually very important. Okay, next, we show you this particular slide, and it looks quite a lot of things, but not to worry, we'll just break them up quickly for you. So you can see the green portion, blue portion, and the yellow portion. So they just represent 3 major portions of the electronics product. So starting from the bottom green portion, this is where you can find all your design requirements and standards. So if you're at the front end of your electronic product doing the design purposes, most likely you have to refer to the standards like IPC 2220 series, and also the land patterns. And the next blue section, we actually go on to look at, this is the bare board section. So meaning that after you have done the design, you send the board out as a Gerber file, or the newer technology later we will discuss is another format. And it goes on to the manufacturer. And here you can do a call out. So the call out will tell the manufacturer to follow according to IPC standards, so they don't make like a mistake, or maybe they will be like some of the parameters or requirements is ambiguous. So if you can do a call out for your bare board, they can refer to this blue section. And then the last section is the yellow portion. that deals with the assembly. So if you can see here the end product, we have the assemblies, and we can also check whether the assembly is done correctly and specify, for example, how the solder joint is going to be created, right? And then we check them, and also including the wire harnessing assembly. So this is like the entire process involve everything you need, starting start to finish of an electronics product. So for the related design, we shall look at 2220 series, which is, if you look at here, we have 21 is the rigid board. 22 is a little bit extra on the sectional rigid board here. If you're looking at flex board, is 2123. 2123, yeah. And then if you have high speed RF microwave, you can also refer to these subsections here. And one of the most commonly used will be for the LAN pattern, because sometimes as a PCB designer, you may have to work on creating LAN patterns. So these are the standards that you will refer to. And then finally, you have 600, 610, and 6012. So these are acceptability in terms of quality acceptance for bare board. And then 610 is quality acceptance for assemble board. And the call out for rigid board is 620. Okay, so what we're going to do is to quickly take a poll, right? Because we have the poll session, and we'd like you to look at the poll session. The poll session is missing. Oh, okay. So yeah, so we'll look at this. So for the participants, can you put in your answer? Maybe about, we give about 6 or 7 seconds. Participants, can you help to do this poll? Because we have several poll sessions, so that we can judge, or maybe get to know like what you are working on right now. So anybody doing the voting or the polls? I didn't see anybody clicking the poll. Anybody? Okay, so yeah, so we look at the poll. So we are viewing the questions, and the poll has closed. So we're going to share the results. All right, so just click share the results. So we have a couple of replies here. So we have like class 1, people designing class 1, and then you have class 2, and then class 3 is about 40%. So majority, maybe you're in a class 2, which is actually the default category of electronics products performance class. And so let's look at level ABC. So we are asking whether you are aware of level ABC. So almost like 60% of the participants, you're not actually aware of level ABC. But that's okay, right? We can learn more about that in the later lectures. So, okay, so I'm going to stop sharing the results and go back to the lecture, or maybe just a presentation. Okay, so next is just to continue to look at some of the PCB design frequently asked questions, like what is the performance class, what manufacturing tolerance level is being used. This has to relate to level ABC, so we're going to discuss about that in the case studies. And also, what kind of copper trace width do you use? Because sometimes when we speak to our participants, they may not have an idea and they just told us that they will just copy from the previous design, which is not exactly that good. So we will show you how you can do a proper copper trace width calculation. And then of course we talk also about going to talk about the footprint use. So if you are a library, you have to create a library. You have different vendors, and then you might be thinking which vendor to use, because different vendors have different numbers. So is it typical or maximum or minimum values, right? And another kind of frequently asked questions will be like thermal VRs, thermal reliefs, are they required for all your power and ground VRs, etc., etc. And why some of the PCB with the same number of layers tend to be more expensive, right? So these are probably the most frequently asked question. Okay, so let's quickly look at performance class. So I guess everybody would have already known, so we just quickly go through. So you have class 1, general electronics product. Class 2 is dedicated service electronics products, which is usually for the commercial electronics products. And then you have class 3, which is the high reliability electronics product. So the main reason here why we have these different classes is because of the communication, right? Because we want to make sure that everyone is sure and confident of what you are talking about, so there's no miscommunication between designers and manufacturers. So class 1 just means that you have all your consumer products, and you can see that they are relatively simple. Function is probably the most, is the requirement that you can have for class 1. So if it works, of the completed product works, then it's fine. Dedicated service is all your, like example, ATM, your photocopier machine. So they require you to have continued performance and extended life, and preferably is uninterrupted service. So maybe you expect them to work every day, and then if they have a little bit of maintenance or breakdown, it's okay, it's not that critical. Class 3 is slightly different. Class 3 means that you must have continued high performance or performance demand. So the product downtime cannot be tolerated, and the product must function when required. So these are very critical kind of PCB boards, and you will see that they are actually in most of the military products, and even in the life support systems in the hospitals, like your ICU, you have all those equipment. So those are class 3. And in terms of class 3, high levels of assurance are required, and service is essential, as in because the product is very expensive, so we expect some kind of servicing of the board or servicing of the product. Okay, so what do they convey, or what do they tell you in terms of this class? So as you can see, the higher the class, it means that the equipment in use, the product or the process or test methods and inspection, all this becomes more precise, more complex, and of course is higher cost and time consuming. And this is a way of communicating the requirement. So if you tell or if you tell your vendor you're doing a class 3 products, then your vendor must have the class 3 facility to support that class 3 product, right? You cannot make a class 3 product and go to any manufacturer with no certification or assurance that they can do a class 3. All right, so this is class 1, 2, 3. So roughly you know what it means, right? So the higher class you make means you have to be really careful about your PCB design. Okay, so class 2 versus class 3. So what's the difference? Right, class 2 is usually the default, and you will see that the difference lies in sometimes certain criteria you specify to your vendor, and also in terms of design, there can be a difference. So we're just going to highlight to you again, the class 2 is commercial and industrial electronics, and then you have class 3, which is high reliability, and there's one more class in case you're working on it. It's class 3A. This is the highest class for space and military avionics. So if you're doing aerospace kind of application, so you probably have to do class 3A. So this is the highest class, which means it's the strictest kind of criteria that you can get. And if you are going to pair them up in terms of like the standards and the performance or the manufacturing performance, so you can look at the next item, which is design versus the performance. So for design standards, we'll use 22. And if you're looking for the manufacturing document to send to your vendor, then you'll be 6012 for the rigid board. And if you are looking at flexible board, then it's 2223, and you call out the 6013, the flexible board requirement, right? So this is how you can, spec them in the contract with your vendor. Okay, so very quickly, we look at an example. This is a lot easier to understand, to show you differences between the two classes or the three classes, because there's a specific number involved. Normally, 600 and 610 is looking at some numbers and some criteria. So you can see that if you have a product that must be designed for class 3, the assembly portion of it has to also conform to a class 3 requirement. So this is built for class 3, assembled for class 3. And all this requirement can be found in the IPC standards, right? So here, we just want to show you, it's a very simple example. Of course, there are many examples of criteria. So we just want to show you the differences in terms of number. So for example, this number here in class 1 can be 0.1. Class 2, 0.1, it means it's kind of less stringent, right? And now, of course, you have class 2.4 and then class 3.8, right? Something like this. So in terms of physical items, you will have all these numbers to represent the different classes. However, design can be a little bit tricky. So we're going to maybe discuss that with you. Okay, let's look at the commonly asked questions. So this is like a case study, and this is like in terms of design. And in terms of design, we can't quantify it with like a number. So over here, we're going to show you a problem statement. So this PCB design has to transit from class 2 to class 3 design. But however, it was rejected, right, when they used the same stack up. So the situation was that the designer was forced to redesign, but basically doesn't know why it was rejected. And so we checked the design and found out that they have a 6-layer stack-up board that was not balanced. Right, so in terms of stack-up, if you want to have reliability, one of the keywords that we say in the guidebook or maybe the certification is that you must have a balanced stack-up, right? So they found out that this 6-layer stack-up was not exactly balanced. And what happens is that when you have an unbalanced stack-up, it means that there may be a warpage problem in terms of manufacturing and in terms of the actual use, because if you are doing class 3, it could be some kind of extreme environment like shock and vibration. And class 3 actually requires you to have high reliability, and therefore the stack up had to be rearranged to meet this requirement. But however, in class 2, right? In class 2, it was not an issue because they don't need to have this, very crucial reliability criteria. Okay, so this is a case study that we're sharing. Next is for copper trays. So for copper trays, like I mentioned, some of our participants in the training, they didn't do any calculation, they just copied from the previous design. So over here, we will give you some idea about how you can calculate the copper with conductors, what we call conductor, the width and the thickness. And you will see that normally they will say that this copper conductor is measured in the weight in terms of ounce. And what we are going to share with you is a new 2152. It's not exactly new, but it has been replaced in 2009. And it gives you a lot more information, and also it includes the FR4 plus polyimide PI material, right? So quickly, we're going to show you. So some of the customers may tell me that, oh, they will use online calculators. Right, this is okay, no issue. There are many online trays with calculators. So the question we would always ask them is, are they kind of reliable, right? Are they kind of reliable? Do we trust them? So this is probably one thing that you need to check. But however, I can just recommend you this EE Web. This is a recommendation because they actually follow the IPC information or the chart that we have. So you can log on to EE Web and look at the tools, and you'll see something like this, right? So you probably can put in like what's the maximum current, the trace thickness, and then there'll probably be a little bit of a question when you try to answer this. Maximum desired temperature or the T rise. So there's a 10, 20, or maybe a arbitrary number up to 40. So what number should you use? So if you're just maybe a class 1 product or consumer product, you might not be worried about that. But if the temperature is a concern, then you need to know how to design this. We're going to show you a case study on this. Now, of course, you have ambient temperature. It doesn't mean it's a room temperature, right? So we're going to again tell you how to put in these numbers, because if you didn't know how to put in the numbers, or you just simply put in the number, garbage means garbage in is garbage out. So you know the answer can be a little bit tricky or questionable. Okay, let's look at how can we tackle this problem of calculating the conductors width and thicknesses. So for this chart, this is the IPC 2152. They will give you this cross-sectional area and current in amperes. So of course, the first thing you have to know is the current in amperes. How do you get this number? Well, this number has to will actually come from your engineering or your circuit designer. You can actually get it from them. Or sometimes they are actually written in the schematic. You can check them, no issue with that. And from this current in amperes, we will check what is the T rise that is allowable in your design. So how to interpret this? Do you use 10 or do you use 45? This extreme case. So let me tell you an easier way to understand this is if you have a smartphone, right? So smartphone is electronics. So what do you wish to have when your smartphone is operating for a long time? Do you want your smartphone to be able to rise to a higher temperature, or you just want to maintain it to a lower temperature? So this is the point. So if, of course, you know, right, it'll be quite scary if your smartphone gets very hot, which is true, which is I'm also scared of. So what I'll be doing for this kind of design is that I will only allow the product to raise to a lower temperature. So then I will choose a T rise to 10 degrees Celsius. So what's the difference if I choose 45? It means I allow this product heat to raise up 45 above the board surface, above the conductor. So which means that this product can get quite hot. So if you see here, the difference will be the number here, right? The cross-section area. So if I choose 10, then this is 10 square mils. And if I go to the next slide, based on the 10 square mil, depending on the thickness or the weight of the copper, I can choose what is the conductor width in inches. And then you can convert it to SI units, no problem. So if I'm using a 1 ounce or half ounce, you know, I can correctly estimate, like with this kind of amperes current, I will design for 10 degrees Celsius, which is cool, means the board will maintain cool. And then I choose according to the thickness of the copper, because more copper means they can be smaller kind of width. But if I have only half ounce, if you see here, half ounce, we will have a bigger width requirement, right? So this is something where there's a relationship. So you need to be careful with that. Okay, next item we will look at is this particular case, right? How are we using this for in a real case study? So again, here is a project that I did with a company, and this is a problem statement. So we have a PCB board subjected to burn-in conditions up to 150 degrees Celsius, which is very high because the original burn-in condition was 100 degrees Celsius, and the board gets actually overheated very quickly and damaged very frequently. So what happens was we checked the design and found out that the trace width are copied over from the previous design, and you know, the designer has no idea how to compute. So then we found out also that the trace width was actually designed, the current is correct, but the trace width was designed for minimal temperature rise, which is not as good because it means that they allow the board to raise to a higher temperature. So once the board raised to a higher temperature, right, this means that you have to, the board becomes hotter. And then what we do is that the recommendation is that we need to enlarge, right? Enlarge for more temperature rise, means the board has to be cooler. And in this case, we need to design for 10 degrees Celsius, not 45, my mistake, because 45 was what it was designed for. But the solution is to make it 10 degrees Celsius. So in this case, we need to enlarge the trace width, okay? So this is where there's a lack of knowledge in terms of the trace width calculations. So this is it's a very good case study that we did for them, and they cannot fix the problem immediately because you need to respin the board. So this is where, you know, knowing this knowledge up front, how to do the calculation is very, very critical. Okay, so we're going to take a short break and do a poll session here, right? So I'm going to do a poll session, and let's open up the poll. Okay, I'm going to launch the poll here, and maybe you can help to you know, put in your answers in the poll. So we're now looking at the questions. So we're asking like how many PCB layers we work with, and then do you plan or decide on your PCB stacker, and do you have any control impedance? Okay, looks pretty good. So a few more seconds before we end the poll. Right, so anybody else? So just to, you know, have a gauge of like participants like yourself, what kind of PCB are you working on? Okay, so we're going to end the poll and share the results. And so based on the results, we'll see that the participants, we have almost 45% are doing more than 10 layers. So which means that you have to be really careful with doing the design because they are usually a lot more complex, right? And then of course, do you decide on the PCB stack-up? So we have about 85% making decisions on your PCB stack-up. So you might want to know like what's the balance stack-up or what contributes to unbalanced stack-up. And the last item is, do you have any control impedance? About 70% said yes, which I would agree because most of the time, almost any designs right now, even if you're not doing them, the complex design, you should at least know what is a control impedance and how to calculate them, right? And then it has to do with like copper conductor trace width and stack up. Okay, so we're going to stop sharing the results and continue. So this is a good way to, you know, check what are our who are our participants. Okay, next item we will be discussing will be the land pattern. So we have land pattern. So what is this land pattern? This is mainly to deal with PCB designer who has to create the library. And again, this is one of the, I would say, most important thing that you start off with. If you have a good library system, it means the downstream will be much easier. Because if you did not create this properly or suitable in a certain manner, then the downstream process may be quite, may have a little bit of problem in the assembly. So we're going to look at this information, how we're going to tackle that. So the question would be, do you actually use the information from your IC package mechanical data sheet? Right. So this here, I'm just showing you an example. Just give me a minute. I'm just showing you an example of a very typical mechanical data sheet with a land pattern. And is this a footprint that you're going to use? Some of the customers, well, half of them said that, yeah, they normally use this. However, if you're just doing a regular consumer-based, not so critical kind of design, is okay. But however, if you're doing like class 3 design or even class 2, you have to be careful in terms of this particular land pattern that you create. Because for the single package, you can get many different land patterns based on the manufacturers. So we're going to tell you that this land pattern or footprint, we call it, you can call it a footprint, but in the IPC standards, we call it a land pattern. It has to, you have to select this according to 2 processes. So the first process is the assembly process, which is the soldering process. Is it like wave soldering, or is it the wave soldering, or is it the reflow? So it's process-based in terms of assembly. And also it can be application-based product use. So this is an example where we're going to show you level ABC. Right, so very quick recap. For surface mount components, we will use IPC 7351. And we will see that not all land patterns are the same. For the same component, you can actually have 3 levels of density, which is A, which is preferred, B is standard, and C is high density. So what does this mean? All right, so we're going to quickly show you a very simple chip land pattern, and you will see that you have a density level A, and this is usually bigger, right? The land patterns or the copper areas can be bigger, and the size of the actual level A. And then you have level B, which is general purpose, when you don't have much criteria. And then finally, you have density level C, which is a minimum solder joint. This is for high density application. So depending on what kind of apps or what kind of process you might have to choose this accordingly. Right, so why do we choose density level A? So let's say, for example, you're doing class 3 design. So class 3 design tends to be high reliability. So a lot of people have, or maybe the participants have a little bit of confusion, is that if they do class 1, they will have to stick to class 1A. And then they do class 2, they stick to class 2B. And then if they do class 3, they have to stick to class 3C, which is actually not the case. So in fact, if you do class 3, you might want to do 3C for shock and vibration, because if you see here, the level A, right? Level A will give you a very robust solder joint, because it means that this particular solder joint has more solder volume on the connection, and it is likely able to withstand shock and vibration. Right, and also in terms of CTE mismatches, this is also another key concept that we teach you in the training, whereby if you have a mismatch, a CTE mismatch between the component and the PCB board, tendency is that there's a thermal expansion that will cause the solder joint to break if you don't design them properly, right? So you have level A, level B, level C. So it's not just, okay, I'm just going to show you back the same slide here, a single land pattern size that you use. So for this kind of level A, B, C, right, I suggest that you might have to maybe understand a little bit more in order to choose the correct land pattern to use for the application and for the process. Because for reflow process and wave soldering process, land patterns cannot be the same, right? So this is also like what we call tolerance of the manufacturing and assembly. And this is where level ABC can be applied here. So this is very short, just a single example. And we're going to show you, again, quick recap. So what is it dependent on? Is dependent on the assembly process related to whether is it manual soldering, wave soldering, reflow soldering, or is it a mixed technology whereby you have SMD and then you use wave soldering? Because wave soldering is for through hole, but there is a mixed technology where you do SMD. So this here, you have to be careful when you choose a land pattern. Okay, the application wise will be like, are you using it for consumer or are you using it for high reliability, right? Again, different land pattern, different process, and different application. Okay, so now we're going to quickly do another poll. Number 3. Okay, this poll is a little bit late, but it's okay. We just want you to know, like, do you calculate a copper conductor waves? And how many ounce copper do you use for your power and ground? Right, just to have a gauge of like what the participants are doing. So yeah, so maybe a majority of you do calculate the copper conductor wave, which is good, right? Which is good because it means that you know what you're doing to maintain the temperature on the board. So we're going to end the polling now and share the results. Right, so we have about maybe 36% who don't calculate the copper conductor wave. So maybe you can consider, or maybe you can just look into your design and see if it's necessary for you to do the calculation. Okay. And also, how many ounce copper do you use for power and ground planes? So you have half ounce, 1 ounce, and a couple of people said don't know. It's okay. So usually we use about 1 ounce is thicker because it has to carry more current in a general case. But of course, you might have certain reason that you're not using 1 ounce, it's fine. All right, so we're going to start sharing the results and continue one more poll, which is to look at the footprint, right? So quickly, we just want to know, like, based on the previous case, because we're going to do a case study, and we just want to know, like, how many of you have to create the footprint, packaging footprint from the database, from the data sheet, and like a majority of the components. And also, do you use mixed technology? Okay, so we're going to just roughly end the poll in a few more seconds. Anybody else who wants to feedback? 28 of you feedback, okay. Okay, so we're going to end the poll here and share the results. Just quickly share the results. So we will see that almost 70% will actually create the footprint. So I guess you would probably need to be aware that the datasheet footprint sizes is kind of generic, and if you have anything specific, or maybe you're doing high reliability kind of product, you need to be careful with that. Okay, so majority components are SMD, right? This is pretty expected, it's okay. So you have probably through hole here. And then you have, this is interesting because one of the key thing about the current technology is mixed technology SMD. Means that you actually do surface mount using wave soldering. So if you're doing this, right, yes, then you really need to know how to create that particular land pattern or footprint. Because the same components, footprint, you can't use the same sizes or dimensions you use for wave soldering and reflow. So you need to be careful with that. Okay, so I'm going to stop sharing the results and go back to one of last example here. So our last example is to, okay, first to look at the problem statement. So we have here this particular PCB board, and what happens is that process engineer have this terrible issue whereby they have a dry joint after 2 to 3 burn-in test cycles. So what's a dry joint? So the dry joint, if we look at the picture, a dry joint means it's broken or it's unconnected. So it means it gives you an open circuit. So after 2 or burn-in cycles, they get a dry joint. And what do? They had no choice but to do a touch up, right? Touch up with solder frequently. And they actually, stop the process and, takes longer to do the test. So on checking the design and looking at the land pattern, we actually found problems. So the first problem is that the land pattern are way too small. So what happened was that the designer, when they designed this, they didn't consider about the extremities of the test environment, which is high reliability. So they made them like level C, which is very, very tight. And also the components are placed very close together. And when we look at the PCB board, the board is actually very huge. So what they're doing is that they just squeeze everything in one small location. So this is not correct. So in the end is that the recommendation is that they have to fix the land pattern, right? So they need to make the land pattern bigger as in level A, so that you get a more robust solder joint, as well as you space the component out more widely, so you don't get like pack them up together because the board is so huge. And this is mainly due to the lack of communications, right? Lack of communications in terms of the level A LAN pattern, and also the requirements of a high reliability board, because this is actually a test board. All right, so this is where I showed you a very simple example how you use the level ABC. Okay, and then the last item that we're going to talk about is just to update you on IPC 2581, which is actually a standard to replace the Gerbil in the future. Of course, it's not immediate, but we are already seeing vendors and equipment machines accepting this 2581, and we expect this particular standards to maybe take off in slowly, progressively, and to replace Gerbil in the future, right? So maybe something that you might be interested to know, so be aware of it. Okay, so that's the case studies that I have for you. So now we're going to do the one last session here is to look at why we want to do a certification. So basically it's just to ensure that you have your knowledge being certified, because sometimes you are a designer who has maybe 5 years or even 10 years, but there isn't any kind of documentation or certification to show. So this is where it's an opportunity for you to do this certification. Even if you're a new fresh grad, you can also do the certification as long as you are, if you're in the environment to do PCB design. And we do have our participants who are just a few months into graduation and working for PCB design company, and they managed to get the certification. So what is inside this certification? So just to quickly tell you, you have 4 items. First is the CID study guide, which you have to receive upfront, and followed by the actual standards 2221, 2222, and T50. So my suggestion is that you have to read and prepare upfront before the training start, either on-site or remote online is okay. And after that, you have a remote exam, depending on-site or maybe online. Participants need to carry out the examination to get the certification. All right, so this is a little bit of certification information. So maybe you'd like to know like what kind of topics do we cover. So my experience with teaching with this CID is that it's quite comprehensive. It means that you're not just dealing with a layout, you're dealing with the complete cycle, as in involvement in the library, right? How the LAN patterns is affected by the design, design affected by the manufacturing and assembly. So you see that it's a very complete list where they look at thermal reliability, physical board principles, like terminology that we talk about or we use in the industry. And then we also have all the surface treatment, as in, do you use HASL lead-free or do you use ENIG? Because ENIG can be expensive, right? And can you replace it? Is there a cheaper version? Now, of course, we talk about documentation and all the basic stuff. So this is like a basic entry level to ensure that you know all the terminology and ensure that you have something to demonstrate that you already know all these terms. Okay, so just quickly to show you the benefits of this using the IPC standards, right? So we have items like you have lesser mistakes or respins. You will know the terminology used in the PCB industry because they can be quite specific. And we're talking about DFM, DFA, and DFT, and compliant to IPC. And in terms of making good decisions, saving time and cost, and improve the product quality reliability. And of course, if you are a manager, right, I'm sure if you have your manager, you actually spend less time to supervise your new staff. and you can communicate effectively to suppliers and all, and you have the experience and knowledge to in line with all the internationally recognized colleagues, right? So again, here we're going to do a quick poll. Let's check the last poll we have. Is that right? Okay. So let's launch the poll. Just do a quick start on the poll, and just to get an idea, like what is your job right now, so then you can know which benefits you can get from the using the IPC, right? Okay, this is the last poll from me, which is the last question that I will ask as an interaction with our participants. Okay, so we're going to close the poll. I think everybody voted. Okay, we're going to end the poll, and then we're going to share the results. So you can see here, well, maybe about 20% is a project manager. And we have a designer and engineering staff is probably about 80%. And do you belong to the manufacturing staff process? About 9%. And then if you're from other industry, it's about 30%. All right, so we're going to stop sharing this result and just continue a little bit more. Okay, so based on who you are, what job you're doing, so you can grab the benefits of using the IPC standards. So for managers, I met a couple of them, and they mainly support the program to send the staff there, as well as they themselves attend the training or the certification, because sometimes they need to talk to the vendor, and it's important to know what the vendor is selling you, or are they trying to upsell you, that kind of thing. So you know how to talk to them. Okay, solve problems, level up. All right, so let's look at how the certificate looks like. So just to show you, so if you successfully certified, right, you can get something like this. So your name will be will be published as an e-certificate, and you can surf or check the status online. So a lot of the companies will use this as a check for the certified designer. So if you say that you are certified, basically you can come to this website and your name will appear here, right? So this is just a little bit extra. And these are just participants of the past certification. So join us in our next online session in July. And that's the end of my short presentation. So I'm going to pass over to Isa to close the session. Yeah.
Yep, great. Thanks, Ms. Cheah. I'll now pass it over to Ms. Yilin to facilitate the Q&A session.
Okay, thank you, Isa. Welcome back, everyone, to the session, and we now move on to Q&A. So I'm going to start with questions that are posed in the chat box, and we have the first one from Sing Chuan. Sing Chuan wishes to know more on the software to generate Gerber files, where and when he can learn of this software. Ms. Cheah?
For the software, actually there are many we call it CAD software that you can use. There's free ones like Eagle, there's commercial ones like Cadence, and then Manographics. So usually the free software are kind of the first thing you want to work with if you're maybe a new person and then you don't have the company software. But if you work for a company, normally the software will be provided by the PCB design company, and you'll just learn from the company colleagues, or sometimes they provide you with the formal training from the vendor. Let's say it's Cadence or it's Mental Graphics. But if you want a free software, they are actually available like Eagle, and I think there's also some other basic software that's free of charge, but is limited to 2 layers. And this is usually what you can do with the software. For the concept-wise, like schematic and reading and all that, the certification will require you to know at least a little bit about those terms before attending. Right, so if you're starting from zero, then I suggest is you get the free software.
Okay, thank you, Ms. Cheah. Xing-Chuan, I hope that answers your query. We now move on to the Q&A box. We've got 2 questions from Recto. The first question, what is the LAN pattern? Is it the trace width? Ms. Cheah?
No, LAN pattern means is the footprint. You normally use a keyword called footprint. That's what we call a LAN pattern. So it's for the components to be soldered onto the PCB board, the copper plates or the copper rectangular pads. That's the LAN pattern, or we call it pad. For conductor trace, we call it a copper conductor. For the copper trace, we call it a copper conductor. It's a conductor. So we have specific names. So if you look at the keyword for trace width, we call it conductor. And then if you are going to look at the component mounting pads, we call it pads or mounting copper, then we call it LAN pattern, which is also known as a footprint. It's just that we don't call it a footprint. In IPC standard, it's called LAN pattern. Okay.
All right. And he has a related question. He's asking if the LAN pattern bracket solder mask from the datasheet to create PCB footprint.
Yes. If you use the level ABC, right? They will actually provide you the dimensions for level ABC, recommendations to do an opening of the solder mask. But some of our customers prefer that the assembler will determine the opening of the solder mask. So it can be either you follow the standard, they give you a recommendation based on the process, or it can be the assembler or the manufacturer's preferred number. So either way, the best I suggest is if you have access to who's your manufacturer, you can ask them, what is the preferred solder mask opening? Is possible, yeah. Okay.
Okay, thank you, Ms. Cheah. So Rector, we hope we've answered your questions. Going back to the chat box, there's another question there from Ms. Arlene Carmona. She's asking how to compute via size with current and temperature factors and temperature factors from Arlene.
Okay, let me look at the question.
How to compute via size with current and temperature factors. 11:09 a.m.
Oh, okay. How to compute the VR size, right?
Yes.
With respect to
current and temperature factors.
Okay, for this VR size, same thing. We have that in the standard 2152, which is there is not just for the copper conductor, the trace width, they actually included a VR. So based on the calculation, and there's a formula, you can actually calculate the VR in terms of the thickness of the VR wall, right? The thickness of the copper VR wall, according to the diameter of your VR. So it's in that standard with a formula. Is that right?
Okay, I hope that answers your question, Arlene. If not, let us know. You can either post it in the chat box or the Q&A box. I go back now to the Q&A box. We have a question from Ing Yu. He's asking, can we have a copy of the IPC 6012/6013 document, or does he have to purchase it?
Okay, my recommendation here is if you want a free copy, it's actually available on the internet, as in the older versions of this 6012, 6013 are free of charge. And you can just download it from the internet. But however, if you want the latest version, normally they don't give it for free in the internet. You might have to purchase it from the IPC agent that sells the standards. So for Malaysia or Southeast Asia, we can go to the IPC shop. There's an IPC shop online for the standards, and you can buy it directly from them for the latest version. But if you just want to check what's inside, and then you don't mind about the older version, you can just download online. It's available. Yeah, if you want, I can just send it to you after this webinar. You just let the staff know your email, and then we can share this with you. It's okay. It's free of charge. Old version. Okay.
Okay, thank you, Ms. Cheah. So Ingyu, we will take note to follow up, but just let us know if you don't receive it within a week or two. Moving on to questions, we have two from Scott. And the first question he's asking is, oversizing trace width for power and ground traces an acceptable practice?
He's asking, is it acceptable, is it?
Yes, oversizing trace width for power and ground traces are both acceptable practice and acceptable practice, I gather.
Okay, that depends on your PCB. So if you have a big PCB board, right? So you have many spaces or maybe a lot of free space, it's always better to put larger trace width for your power and ground. So this is acceptable, provided that you have enough space on the board. But if you have a very small board, you don't have enough space, and you can't do that. So yeah, it depends on the situation. But it's acceptable. It's always good to have bigger traces, actually. Yeah.
All right, thank you. Second question from Scott, is trace width a big concern for signal traces? Is the trace width a big concern for signal traces?
Okay, so if you're just a regular trace and if the current is not high, because the trace width for signal also depends on like if that signal is carrying a high, is it a high impedance or is it carrying a higher current? So it depends on that current value. All right, so the other reason is control impedance, because there are a lot of times the trace width will determine what is the control impedance of your board. So it does matter for the signal, because for signal, normally we do control impedance, right? So it's either you know the current and then you know the control impedance, then you are very concerned about the trace width. But again, trace width, if you have more space, we can always make them bigger. And also, we make them bigger is because it's easy to manufacture. Because if you make them too small and too fine, normally the vendor will probably charge you more because it's difficult to manufacture fine lines, right? So this is, yeah, my answer for that.
Thank you. Thank you.
Okay.
Yeah, Scott, if you have follow-up questions, let us know. We hope we've answered you appropriately. And we've got a question from an anonymous attendee. The question is, does IPC have standards on PCB finish plating related to pogo contact pads versus solder pads?
The standards only like have a certain recommendation. So in terms of this normal pads and the pogo test pogo pins pads, right? It's normally about the goal thickness. So depending on like if you do how many tests you have, like thousands of tests like maybe per minute or something, then they will recommend you to have a thicker gold plating. And then for other platings, again, depending on like how many times you use it and what's the purpose. So they do have some recommendations. And you can check that according to class 1, class 2, class 3, and also according to the application of how to use this particular pad for the gold plating. Yeah, it's the thickness of the gold. Okay.
Okay, I think we missed a little bit on the last part of your question, Sulan. Maybe of your response.
Okay, it's about the pogo pins, right? He's asking where's the difference between the normal one and the pogo pins for the pads. It is dependent on, let's say, how frequent you use these pads to test the which lands on the pad. So usually there is a thickness, a gold thickness involved, and they would do a recommendation. And if your usage is very high for the testing, normally the gold thickness has to be thicker. And the numbers, this is just a recommendation, and you can find them in class 1, class 2, class 3. So we are expecting that if you do this kind of testing, then your land pattern or pads have to be a higher reliability in terms of this frequent usage and what we call maybe a little bit of extreme environment. Is that right?
Okay, thank you, Ms. Cheah. Another new question has just come up, an anonymous attendee as well. And he's asking, may I know when is the next CID certification exam date? And in relation to that, when do they need to register? And is there a deadline?
About our next online session is 1st to 9th of July. And we have to register at least like 3 weeks before the training starts. The exam date is actually on the 9th of July for this upcoming class. And you must remember that you have to receive the textbooks or the guide and the standards to prepare before you attend the training. So 1st to 9th of July is the upcoming class, and 9th of July is the exam date. And you need to receive or register as soon because we have to close like 3 weeks before the training for you to receive the manuals to study, because you have to study first before you attend the training. Yeah.
Okay. Another question from anonymous attendee. Do we have an IPC standard on what aspect ratio should a fabrication vendor need to fill a drill hole?
Yeah. In fact, we did. In our training, it's one of the key things that we talk about for level ABC. So for aspect ratio, tendency is that we prefer to have a low aspect ratio compared to high aspect ratio. So there is a level ABC number you can follow. So it is in the standard, 2221.
Okay, thank you for that. So I'm just going to close the session with one last question, seeing that we've overrun a little bit on timing. Is there any criteria to take the online IPC CID certification?
Currently, we don't have any criteria for the basic entry level. Is as long as you're interested, you're in the industry, you work with it every day as part of a job, you can attend. We have attendees like with 5 years experience, with 10 years, some with more than 15 or 20 years experience. They also take the certification. And for fresh graduates, we have attendees like 2-3 months, they are on the job, and the supervisor asks them to attend this training to get the certification. So for this entry level CID, there is not much criteria. Yeah, so as long as you're interested, you're doing this job, you can register and sign up.
Okay, thank you for that. I gather there are no more questions, so I'm just going to sign off here and hand the session back to Eza. Thank you very much, ladies and gentlemen, Ms. Cheah, for your participation.
So I'm going to stop sharing, right? And yeah, stop sharing. Okay.
Great. Thank you, Ms. Cheah. Thank you, Yilin. for that. Before we go, we would really appreciate if you could spend some time to give us some feedback on today's session. We're going to give you a couple of minutes to provide us with feedback. All right, I think most of you have already given us feedback. So we want to thank you again for joining us in this session today. Thank you again, Ms. Cheah. And we hope you have a good rest of the day. Please feel free to contact us on the contact that is on your screens right now. And have a good day. Thank you.